Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Strength of Materials in 6. The topic of this tutorial is a mixed bag of possible exam questions, round 4, question 1. The formulas used are included in the video. The question is also posted in the description box below. We have been asked to issue a cautionary note. Some of the formulas used in these videos, which are taken from DP exams and past papers, do not appear in most textbooks or the formula sheet attached to your exam. You will need to know them in order to do some of the sums. They appear in the beginning and end screens. Let's get straight into it. Our questions state, a 1 meter long solid shaft is supported at its ends by bearings and carries a 2 meter diameter pulley with a mass of 300 kgs at the center. The pulley drives a machine below the shaft at 30 degrees to the horizontal plane. The tight side tension of the belt is 4,000 newtons while the slack side tension is 1,000 newtons. Assume the allowable shear and principal stresses to be 45 megapascals and 80 megapascals respectively. What we want is now to calculate the maximum torque transmitted by the shaft. Number 2, the maximum bending moment on the shaft. And 3, the equivalent torque and equivalent bending moment. And finally, the minimum shaft diameter required by considering both stresses and give a reason for choosing the selected dimension. First things first, we need to calculate our maximum torque. So, go L equals 1 meter. The diameter of pulley is 2 meters. Our mass of pulley is equal to 300 kgs. Theta is 30 degrees. Our tight side tension, T1, is 4,000 newtons. T2 is 1,000 newtons. And our shear stress is 45 times 10 to the 6 pascals. Our regular stress, our principal stress is 80 times 10 to the 6 pascals. Okay, now first things first, we are going to do the torque. Torque equals T1 minus T2 times R. So, what we're going to do now is say T1, which is 4,000 minus 1,000 times 1, because that is the diameter, that is the radius of the pulley. Radius is half your diameter, so 2 divided by 2 is 1. So we've got 4,000 minus 1,000, which is 3,000 Newton meters. So our principal torque is 3,000 Newton meters. Now next sum, number 2. What they want is our maximum bending moment on the shaft. So 2, first things first, do we need the weight? Is M times G. So weight equals 300 times 9,81, which equals 2943 newtons. Weight will be important later. 2943 newtons. Okay, now FB. Force for bending equals T1 plus T2. 4,000 plus 1,000 equals 5,000. So FB is, F sub B is 5,000 newtons. FV equals W plus FB sine theta. So we have 2,943 plus 5,000 sine 30. FV equals 5,443 newtons. So 5,443 newtons. Now what we're going to do is do FH. FH is FB cos theta. So this is 5,000 cos 30. And that equals 4,330,127 newtons. F horizontal. The FV, it means that's the vertical component of the force, and FH is the horizontal component of the force. 4,330,127 newtons. Now we've got our, now we need F. F equals the root of FH squared plus FV squared equals FH, which is the root of 4,330,127 squared plus 5,443 squared equals 6,955, 304 newtons, which is F. F equals 6,955, 304 newtons. Now all we need to do is take F, our value for F, and put it into our find. That's what we needed to find, was F. All these steps just to find F. Because F, we're going to find M equals FL over 4, which equals M. So it's 6,955, 304 times 1 over 4. So M equals 1738,826 Newton meters. Okay, so what we have done is we have done question 2 now. Now on to question 3. We've got M here, because we'll need M for question 3. So, how question 3 goes is it wants the equivalent torque and equivalent bending moment. So, question 3, TE equals the root of M squared plus torque squared. So, this will equal the root of 1738,826 squared plus the torque is 3000 squared. Now what we're going to do is write our answer. Put that in your calculator and write your answer. 3,467,494 Newton meters. Now TE equals 3,467,489,94 Newton meters. The next part of this is ME equals 0,5 times M plus TE. So it equals 0,5 times 1738,826 plus 3,467,494, and that equals 2603,161 Newton meters. So ME is 2603,161 Newton meters. So now the final question is question 4. The minimum shaft diameter required by considering both stresses, and give a reason for choosing the selected dimension. Alright. For TE equals pi d cubed over tensile stress over 16. Now what we do is we formula manipulate. 16 comes up, TE times 16 divided by pi times equals d cubed. Now all we have to do is cube root it. Now TE is the cube root of 3,467,494 times 16 over pi times 45 times 10 to the 6. And D equals 73,213 millimeters. Right, and the next part, so D for that, 73,213 millimeters. Now the next part is ME equals pi D3 over stress over 32. So we do exactly the same thing as we did with the last one. So ME equals ME times 32 over pi times stress equals D3. Now we cube root that. ME times 32 over pi times that. Now, what we need to do is put our values in. As we go, ME is, this is the cube root of 2603,161 times 32 all over pi times 18 times 10 to the 6. And that you put in your calculator and you get 69,205 millimeters. Now the diameter that we choose 73,213 millimeters because it satisfies both limits, and that is the whole answer. If you found this tutorial helpful, please consider giving it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day, looking forward to seeing you in the next video.